All right, guys, this is our last lesson of e-learning. We're going to do a little bit of review this week, and we'll be doing an in-class assignment. And then we're just going to start reviewing some semester stuff just to make sure you kind of leave out of here with at least a summary of what we've learned this semester. But this is it. This is the last video lesson. And hopefully shouldn't be too bad. All we're looking at today is different applications of where you can use the determinant. So you will need your calculator for some of this, but this very first thing we're going to talk about, Cramer's rule, you should be able to do this whole thing without your calculator. That's kind of the point of it. Mathematicians develop this rule and notice that this works to solve any square system. So anything that is 2 by 2, 3 by 3, 4 by 4. And it's a way you can use matrices to help you solve it and not have to go through the whole process. So in order to set this up, the first thing you have to realize is that we're going to end up finding multiple determinants. So if it's a 2 by 2, we end up creating a D matrix, a dx matrix, and a dy matrix. If you look at the box in the bottom, if it were a 3 by 3, there's actually 4 matrices we would make, D, dx, dy, and dz. So to create those matrices, the first one, D, is just all the coefficients. But then dx, you replace the x column, where the x coefficients were, with actually the answer values from the end. And then for dy, you take the y column and you replace the answer values. Then to get the answers, all you have to do is set up these two fractions. To find x, I have to do dx divided by d, and to find y, I have to do dy divided by d. And d in all of these refers to finding the determinant. That's why you see these flat lines, and it's not the brackets for a matrix. All of these are asking you to set it up and find the determinant of those 2 by 2 matrices. So let's try one. So looking at number 1, it says I have to use Cramer's rule, so I want to see all of your work for this. I know you know how to put this in your calculator now, but I need you to show the work of using Cramer's rule. So I know that I have to set up 3 matrices, D, dx, and dy. So your first goal is to set those up. So the first one, the regular D one, is just the coefficients. I get 3, 4, 5, 3. Then here, the dx one, this is what I need you to pay attention to. We're looking at that answer column, and that's going to replace the x part. So 1 and 9 are going to end up here, and the 4 and 3 stay exactly the same. So that x column gets replaced. And then for dy, we do the same thing with the answer column. The x is going to stay, but the y column is going to turn into the answer column. So that's going to turn to 1 and 9. Okay? Then you have to evaluate the determinants for each of these. So this one's going to be first diagonal minus second diagonal. The first determinant is negative 11. The dx determinant is going to be 3 minus 36. Dx is negative 33. And the dy determinant is 27 minus 5. So dy is 22. And then to get the answer, Cramer's rule just says I have to get x, I'm going to do dx over d, which is going to be negative 33 over negative 11, which means my x answer is 3. And then to get y, I'm going to do dy over d, which is going to be 22 over negative 11, which means y is negative 2. So that means my answer for this system is 3 comma negative 2. Okay? And I know it's hard for you guys to imagine, but prior to calculators, this was a much more efficient method for some of these bigger systems than what we did back in chapter 7, where we did all the plugging in. So we're going to see that now with a 3 by 3 matrix. And we're going to cheat a little bit because we're going to use our calculator to find the determinant. I'm not going to make you do that by hand. So, first thing for a 3 by 3 is we need 4 different matrices. We need D, dx, dy, and dz. D is going to be all of the coefficients that were originally there. 2, 2, 3, 5, negative 2, 6. Dx, we're taking the answers and we're going to put them in the x column. So that's going to be 12, 1, 22. And then this is going to be negative 1 to negative 2, 136. dy, we're going to leave the x column alone, but then the y column is going to switch for 2, 1, 22. And then that's 136 still. And then dz, the x column stays the same as the original, the y column stays the same. And just watch your signs. The z column is going to switch out. So I hope you're seeing all that switching. I'm going to go back and highlight it just so you guys see this switched out for dx, this switched out for dy, and this is what switched out for dz. So then I am going to tell you just use your calculator and find each of these determinants. Oops. So this one, if you find the determinant on your calculator, you should get 55. The next one, you get 110. This one, you get negative 165. And for dz, if you type that in the calculator, you get 55. So then all I've got to do to get my answer is I'm dividing all of these by d to get the answers. So then this one turns into 2. dy, for y, I'm going to end up getting negative 3. And then for the last one, I get positive 1. So that's the answer to that system. Okay? That's pretty much the most complicated thing we're going to do today. We're looking at 2 other things that you can use the determinant to help you find that are kind of cool. So this next one, we're looking at actually how you could find the area of a triangle given its coordinates. So if you went back to when you did this in geometry, you'd have to graph this out. You'd have to use a distance formula to find the base. You'd have to figure out distance formula again to find the height. It's all sorts of craziness to try and find the area of that triangle right now. Watch how easy this is. All this says is that you're going to take the points, and if you notice, these go across. So you're going to take each of the coordinates and put them across, but that won't make a square matrix. So that last column, you're just going to fill in with 1s. So I'm going to go ahead and fill in the formula. We'll talk about that plus or minus sign in a second here. But I'm going to put in the first point I'm going to put in is 1, 0, and then it's going to end with a 1. The next point was 2, 2, that's going to end with a 1. And then 4, 3 goes here, that ends with a 1. Remember, those symbols mean you're finding the determinant. So you would just type that in your calculator. If you wanted to do one of the by hand methods that I told you in a previous lesson, you could do that. But this just means you're finding the determinant. So we do that on the calculator. If I could spell, that would be good. On the calculator for this particular one, it says negative 3. And this is where the plus or minus comes in. You're going to pick whichever one would work better with what your determinant is, because hopefully you realize to have an area, areas have to be positive. So since this is negative, we're going to do negative 1/2 times 3. And that gives us a not really interesting area, but an area of 1.5 square units. Oh. Okay. So go ahead and try number 2. And I'm just going to go ahead and fill it in. The formula would have plus or minus 1/2 of 0, 0. Make sure you put the last number as 1. 4, 1, 1. 2, 5, 1. Now it doesn't matter what order you put the points in. So if that was a question you may have had, doesn't matter what order they're in, you can just plug them in. And then that's going to be plus or minus 1/2. Type that in your calculator, and you should get 18. And then since that's positive, we're going to take the positive one. And that's going to give us half of 18, which is 9 square units. Okay. Last type of problem is kind of related to that, is we're going to be using, it's the same formula, but we want to talk about what happens if your determinant comes out to be 0. So that essentially would be telling you that your area was 0. Well, the only way for you to have an area of 0 is if the top line that was in like that last triangle fell on top of the other one, which would mean that it's all a straight line. So that would tell us an important fact geometrically about them, that they're collinear. That's just a fancy word that means they stay on the same line. So in these directions, they want to know if they're collinear. We're using the same formula we just did on the last page, and we're going to find the determinant. The only thing we're not doing is the 1/2, so I guess it's not exactly the same. but it's the same kind of setup. We're putting that last diagonal of 1s in, and then you're going to find the determinant on your calculator. So you're just typing that in to see what happens. And this one ends up equaling 0, which again, what that is physically telling me from the last type of problems we said is that it's no longer a triangle, that these are actually all flat together, which means this is on the same line. So this is collinear. So go ahead and try number 2 and see if you can figure out if it's collinear or not collinear. So here's the setup. It should be 2, 4, then a 1, 3, 1, then a 1, 6, 4, then a 1. And if you type that in your calculator and find the determinant, we get 12, which means this is non-collinear because it didn't equal 0. Okay, you have a couple problems to try on ClassKick just to show me that you understood what we covered today. And then there's just a short homework assignment. I think there's 6 problems. It's not a lot, just enough for you guys to practice this stuff because it will be on the in-class assignment. And I do want you using the methods I taught today to do that, not just going back to the methods that I taught earlier in the chapter. Okay? Have a great rest of your Monday, and I will see you guys tomorrow.